Well, good morning, and here I am in my pyjama, talking about stuff. You thought it was an April Fool, didn't you? Well, it isn't. And we start with the first topic. So, my first topic is on software projects and why they are more difficult to manage than classical projects. Now, when I say more difficult, what do I mean by more difficult? Well, if you work as a project manager, you probably stumble upon this kind of research. This looks a bit complicated, but this basically shows the overshoot budget, the average budget overshoot for different kind of projects. And well, where is it? Yeah. And what we can see here is that the average budget for construction is pretty low, but more importantly, it stays pretty stable. It's around here compared to the size. That means that, we pretty much know what we're doing, and so we can keep it constant. But if we look at budget overshoot for software projects, is extremely high, and it grows based on the project size. So why is that? How is it possible? Now, I don't remember this research from when it is, but things haven't changed in the past years. So how is it possible that in the 50 or more years that we're doing software projects, we still haven't nailed down a way to prevent overshoot, or at least to keep it pretty much constant? I mean, what this graph shows is basically that when you start a software project, you pretty much don't know when it's going to end. And in my personal experience, that's pretty much correct. So what's going on there? Well, my hope today is to break it down and at least give some insights on why that happens. I'm not really going to give a solution, because I don't believe a solution to this problem exists. But knowing the problem, accepting the problem, is the first part to work around it and maybe try to have some more predictable projects. All right, so let's start. Let's start with some assumptions, and also start with a simpler case. So let's assume that you want to build a house. So let's start with a construction project. And also here, I'm only going to worry about time. So, a project has, say that you're a project manager, you want to determine how much will it cost for your project and how much time will it take to build. Analyzing both for this hypothetical scenario doesn't make much sense, in my opinion. Let's focus on time, because we will see later that time is really the main driving factor for software projects when it comes to costs, not so much resources. So let's talk about time. So say that you want to build a house, how would you approach it? Well, there's a couple of things, right? You list all the tasks that you want to do, and you try to say how long those tasks will take. Say, for instance, that you need to build a foundation for your house. Then you need to build walls. Then you need a roof. It makes sense, right? But of course you also need plumbing. And you also need maybe to paint the house. And in the end you want to sell it to make up for the costs. Alright, this is pretty easy. And say you want to structure the work. Now I'm going to draw a line on the right that's going to represent time. So here we have time. Okay, and this is an arrow. Okay. So, alright, say the foundation is something you do pretty quickly. So, okay, takes so much time. The walls is probably what's going to take the longest to build. Okay. And only after you build the walls, you can tackle the roof. Of course, building a roof without having walls underneath is kind of difficult, so that makes sense that things are organized in this way. And so what I'm doing here, I'm just distributing things over time. But then when it comes to plumbing, I can probably start plumb the house, after only some walls have been done. I don't know how long it takes to prep a house, but I can probably start it when the walls are not completed or where they're laying. Maybe I start to attach there or start to do the bureaucratic work. Same with painting. Painting, I can start it probably somewhere here and go later, because I can start paint the wall when they're almost done. And the process of selling the house, well, I can start selling the house from the get-go. So I have plenty of time to find a good buyer or something like it. All right, that's cool. So this, of course, if you know what you're doing, I'm not a construction worker, project manager, but you kind of know how long all these steps take, and then you can put them all together. You can assign workers to it, and then you get a pretty reasonable estimation on time and work. By the way, this kind of graph or chart is called a Gantt chart. This is a pretty classical tool for project manager to just organize the work and see how that is that goes forward. All right, that's cool. So, as you can see, for a project estimation, so a project budgeting, it's very important to know how long any single task will take. And also it's important to know the cost of the tasks, right? How long will it take, but also how predictable they are and things like that. Now let's reflect a bit on the tasks themselves. There are different kind of tasks, right? If I put a line here, I would say that you have cheap tasks. Don't like this color. You have cheap tasks, right? And then you have expensive tasks. All right, that's easy. So of course, in here by cheap and expensive, I really mean in the sense of time. You have tasks that you can do very quickly and tasks that you can take longer to do. Yeah, that's what, because remember earlier we said we're not only going to focus about time, but of course this applies also to cost as well. So cheap and expensive tasks, going short, long, call it whatever. But you also have other kind of complexity. You also have other kind of measure here, which is the measure of complexity. You have the simple tasks. And you have the complex ones. Now, what do I mean by simple and by complex? A simple task is a task that I know exactly how to resolve. If you ask a plumber to put plumbs in your house, to do some work in your house, they know exactly what they're doing, right? They're professionals. So they say, yeah, I need this number of pipes, I need to break this number of walls, I need to do that. Okay. As likewise, if you're building a wall, right? If you try to build a wall, it takes a long time to do, but yeah, it's one brick after the other. There's not much to it. You know exactly where to put all the bricks, and you know exactly where to put all the walls, and in the end you get a house. All these tasks are simple ones. But from what I said now, you can probably guess that there is a spectrum of simple versus complex. So if building a wall is somewhere here, because it's a very simple task, but it also takes a very long time. When you build a house, it's probably one of the things that takes the most. Plumbing, on the other hand, is more around here. It takes definitely less than build a wall, sure, but it takes less time, but it's also more complex. Maybe you have to investigate a little bit where the wall goes and where the pipe goes, and make sure that you can easily access it in case of failures and things like that. All right, so that's what simple means. Simple are those tasks that I know exactly how I'm going to resolve. That's on the left side. On the right side, we have complex tasks. Complex tasks are tasks that we don't know how to resolve. And that is interesting. So what I mean, and I don't know how to resolve it, it's just that you cannot have a certain solution to it at the beginning. For instance, in our example of building a house, we have one step, that is to sell it. And while that doesn't look like something difficult, it still has a certain degree of complexity. If you're building a house in a new neighborhood, you have to find which kind of people are interested in that neighborhood and which kind of a marketing strategy you can use to sell it at the highest price possible. All these questions are not easy to answer before you start trying to sell the house. So you can't know the exact price for which you're going to sell it before selling it. And that also depends heavily on factors outside of your control, like market conditions. So definitely selling the house would be somewhere here. Well, or here, depending on how good you are, I guess. So yeah, simple tasks, we know exactly what we're doing. Complex tasks, we don't know the exact outcome. That doesn't mean that we don't know what we're doing, of course. A salesperson knows how to sell stuff, but selling things is still complex. And the complexity also has nothing to do with time of the resolution of the task. You can have complex tasks that take very little to resolve. Right? I don't know, maybe not selling the house, but in the case of the plumber, if there is a leak somewhere, yeah, he doesn't know exactly. See that after building the house, you have to patch a leak. The plumber does not know exactly where that leak is, which is fine. And by the magic of pausing and resuming, I'm in my office. Yeah, I should have started the talk here directly. But that's fine. So I was saying, finding a leak is not necessarily complex to fix it, right? Once you find it, you just patch it right away. But it can take some time to find the exact place where that leak is. So patching a leak would also be somewhere here in the complexity, right? You have ways to understand where the leak is, but to find it precisely can take some work and some effort. That's cool. All right. It's also worth to mention that every time you do something new, something that you never approached before, that automatically makes it complex. I personally have never built a wall. So even though for an experienced worker, building a wall is on the simple part of things, for me, that's on the complex side. I have to figure out how to do that. I have no idea how much can I lay, how fast can I go right now. So for me, building a wall would be here. Something like that. So complexity is a very personal thing, and of course you can also access complexity is a very personal thing, and of course you also access literatures and training to make things complex become simple. So if I train to be a worker, I become an apprentice or something, then I start to know how to build walls, how to build roofs, etc. And then all those things, they go on the simple side of complexity. Okay, so let's go a bit back here and let's see this Gantt chart. Now, what we have here, also with only these few examples, we can see that most of the tasks, like all these ones, they are simple tasks. And again, simple does not mean that they're easy. Simple does not mean that they don't require time, but it means that we know what we're doing. All these tasks are predictable. The only one that is not predictable is the selling. And that's generally true for construction workers' projects. We build a lot of houses in the past thousands of years, and while the techniques and materials have changed, we have a lot of experience there. But this is also true for software projects, right? Also in software projects, most of the tasks are simple tasks. So let's start to see why is it different. And it's also worth to mention that because simple tasks, we know exactly what we're doing, it's also true that we know exactly how long they will take. There's gonna be hardly surprises when you're building a wall. You know what you're doing, we did that millions of times. And the same goes for the other things. The only thing that can go wrong and that is unpredictable is selling, because maybe you don't manage to sell at the right price for the beginning, or maybe some regulations comes in that you have to touch other stuff, all these kind of things. So let's summarize. When building projects, when planning for projects, in construction projects, but also in software projects, most of the tasks are simple. And simple tasks are the ones that are easy to plan for. That also means that simple tasks, they buy us time to tackle the complex ones. Why did I put start of selling here when we laid the foundation of the house? Because if it's completely unrelated to the construction of the house, I know when the house is going to be completed, which is here, and I have all the time in between to sell it, really. And maybe it's going to be easier to sell it once I am somewhere here that the house is almost done or halfway through, so I can start to show the location and things like that. But I can start from the beginning. There's nothing preventing me. So what we have here is that simple tasks, they buy us time to tackle the complex ones in time. Okay, cool. All right. Now let's start to see what makes software project difference. I already mentioned that I don't know how to build a wall, but if I get some training, then the wall becomes simple for me. Tasks move around this board. Same as fixing a leak, which was the small one here down on the right. Once I know where the leak is and I patch it, I know exactly how to deal with any leak in a similar location. So maybe I say, okay, now I know how to look for a leak in this problem. But of course, every leak is going to be different, right? So we have two kind of things here. So we have two scenarios here. For learning to build a wall, which was this one, once I learned it forever. I'm not going to forget how to build a wall. I don't have to learn it again. But when it comes to patching a leak, well, yeah, I learned that specific leak, but the next leak is going to be somewhere else. So, yes, this what I wrote here is not really true. The leak problem stays around here in complexity, not here. This doesn't happen. That's important to keep in mind. Okay, so how are software projects different? Well, the main thing about software projects is that they are not real. We don't have to deal with reality, with the reality of things. We don't have to deal with the material cost of things. I'm cleaning up a bit in the meantime. So that is a very important thing to keep in mind. Let's go by example again. Say that, as we said, building a wall is somewhere here. I can make building a wall cheaper by inventing. We can make it cheaper by inventing power tool and or by doing other stuff, but in the end we still have hard limits to how simple we can make it. So yes, we can build all the tools we want when it comes to raising walls, but we still have to wait for cement to dry. And even if putting the cement takes 1 minute, it still has to wait. We still have to wait. And the same goes for a lot of things in real projects. Even if we make them super efficient, we still have the physical properties of the objects that slow us down. So we reach a minimum where it's not convenient anymore to make it more efficient. We have diminishing returns. Software projects, however, they don't have that problem. In software projects, we have no material cost on things. That means that if I am dealing with something complex, the moment I solve it, this becomes simple and cheap right away. I have no material. I have no cement to wait for drying. That means that that problem has no cost anymore. And of course this is true also if I have something here in the complex chip side of things. Oops, wrong color. Complex chip side of things goes there. Still wrong color. So yeah, that's an advantage of not having materials. We build virtual things, and virtual things are built on our own whim. Furthermore, the things that we build to make software simpler is still software, which means that we can reuse it as is in the next projects. What this means is that we basically never have the translation from complex but costly to simple but costly. This never happens. Even if it happens that something that we can make simple takes time then to execute, we can still do it without, we don't have to watch it. We know how it goes, we can inspect. And again, we're not building real things, so any damage that can happen, well, it's not real as well. We can fix it later without issues. There are exceptions to this, but they are very few. And that is the problem, really. What happens here is that the first time we encounter a problem is... So let's take a step back a little bit. So, as I mentioned before, the first time we encounter a problem, that is in the complex spectrum, right? Is somewhere here. We never dealt with it before, and thus we don't know how to solve it. We have to investigate. Maybe with our experience we know pretty much the solution we have, but in order to put it in one spot inside this, well, I need to start work on it, and I need to already start invest time only to know where in here it is. Maybe it's going to be here, maybe it's going to be here, I don't know. It can be anything. And then once I discover the problem and I fix it, it goes in this other part of it automatically. But not only that, very likely it will be also in the simpler part of it. So they will go somewhere here. So what does it mean, and how does it make our problem of building projects? Well, the thing here is that if you remember, the complex projects are the ones that we don't know how to estimate. And for how we build software, in the end, the only thing that we are left with are complex problems. All the tasks in a software development projects, why most of them are simple, cheap, most of them are simple and cheap. So that means that their time of execution is nothing, can be ignored. For instance, coding is somewhere here as complexity goes. Coding is not a complex matter, and yeah, it requires some time to code something, but it's not complex at all. Other things that are there are running tests. Also, they're somewhere here normally, if you are automating them. And if you cannot automate them, they stay in complex and they have the same problem of the leak of the plumbing. Is that anyone is its own thing and we cannot really fix it. So if I try to write I should have prepared another frame. Where is it? So if I try to if I try to write a Gantt of software projects, it's gonna look like something like this. I'm not gonna put the tasks named like the other time, but could make straight lines. So if I try to do Gantt, it's going to be a full errand because I have, a simple task here, a simple here, a simple here, a simple here, and then I have a few complex ones, 2 and 3. But the thing is that because once we know how to fix simple things, we know that forever. And because we don't have material costs, fixing simple tasks they become very quick. Then the Gantt looks something like this, that for the simple ones is very short time, and for the complex ones normally you go in this direction, because those you don't know how to solve and you have to figure out how to do that. And even if you plan for it, good luck, we don't know the solution, so we have no idea how long can it take. And I guess for me this is the reason that I think why software projects are constantly in overrun. We don't really bother with the simple tasks. It's not a problem. If a simple task takes too long, we probably have ways to make it shorter. OpenAI is going to help a lot on that matter. And all you're left with are the complex tasks, the ones that you don't know how to fix, the weird implementation that nobody knows how they work, or the customer that comes and says, I want the moon, and you say, I cannot deliver that. They are all complex. So it goes without saying that this way of planning for a project doesn't really work for software projects. And it shows in the research. The research, we see that all projects are in overrun. As long as we plan in this way, it's not going to work. So how to fix this? I don't know. Nobody knows. That's the nature of the problem. There is no fix to this problem. That's the thing we have to come to term. No fix. So long as we plan projects in a classical way, so long as we allocate budget in a classical way, this problem is just going to be here. And don't trust anybody that claims they have a fix for it. They don't. They are asking for your money. And this is not going to be a popular statement. I also don't. I mean, I'm a consultant, I shouldn't say this, but I don't know how to fix this problem. I have strategies to mitigate it somehow, but maybe we'll talk about those later in time. In the meantime, thanks for listening, and see you soon.